everyone, hello. This time we still keep on going to solve the differential equation. This time we solve a special type. This type is we call homogeneous. Homogeneous is a kind of why homogeneous is because they have mixed y and x, and normal is y over x. So if you ask me how about x over y, I think that's maybe different. Yeah, I did not try it, but if you are interested, you can try it. But right now, this type is y over x, and f equals to y of x. And what we doing is that we suppose there has a v equals to y over x, and then we change y equals to vx. Then we can change the dy over dx into the v style, right? So let's give an example, and I will only do one example here. Okay, so here is dy over dx. Remember what we talk about. What we talk about the what we talk about the differential equation is in the equation they have both differential as well as the what function, right? So this is a function, right? So how do we show that we make that v equals to y over x? Okay, so then dy over dx, so we can see here, right? dy v dx is equals to what? V plus x times dv over dx. The right side is 3 times v, am I right? So this divides, so it's only 2, right? Then what we're supposed to do, we will divide by v in the left side divided by x on another side. So divided by 2v, so it's dv over 2v, am I right? Equals to dx over what? X, am I right? So if in this way, what we solve next, we will be doing integrate on both sides. So this will be what? This will be ln, right? ln what? 2v, right? Of course it's ln 2v, and what? ln 2v, and this will be the 1/2. Yes, this will be 1/2, right? So equals to ln x plus c. Why have a c? Because you think about this one, ln x plus c, if we do the derivative, it will be what? dx over x, am I right? Because c derivative, any kind of constant derivative is 0, right? So if this is 1/2, so you can move here like ln, then 2v square root, am I right? Equals to ln x plus. This we can also write in ln k, can write? We can make the c equals to ln k, right? So, anyway, that's not important. You don't ask why c equals to nk. We just suppose can be, right? It cannot be, right? So we make this just make this a little simple, okay? So since their base have the ln, so if their base are same, right, and they're equal, so their number should be same. So square root 2v equals to what? Is plus is times, right? Kx, right? So 2v equals to k square x square, am I right? And then v equals to k square x square divided by 2. And v equals to what? I remember it's y over x, right? So v equals to y over x equals to k square x square over 2. So y equals to what? K square x to the third power divided by 2. Right? So we already solved this um, equation uh, already, right? So as I last time I talked about how we solve this kind of equation, we just we finally substitute the derivative part, and only it changes the normal equation. So for normal equation, we already know how to do that, right? We already know how to do normal equation, right? Yep. Okay. So that's it. Today's example is in fact is quite simple. They have very hard and deep examples. Um, since we don't have time um, to elaborate those things, so if you're interested, you can doing that at your end. But only speaking, as I observe for homogeneous differential equation, they have a very limited scope. What I mean limited scope is for this style is very unique. You can only solve like y over x this kind of style. If we change change the style of this one, you will become very hard. You only use the homogeneous way of solving. You cannot solve. You have to use other way to solving it, and then it will become elaborate. I think I'm trying to figure out different kind of the way first to solve the differential equation, and then we'll have one section to combine them together. So we will really have diving for very deep and hard one to see if we can get finally substitute the um, differential away. Okay. So that's it. Today's a quick session. I hope you can learn something from this. Okay. Thank you very much and have a nice day. Bye bye.